Okay, so I'm not really headed anywhere in particular with this. We may end up making up a problem that we solve. I was just tutoring someone today about related rates, and it got me thinking. So we're just going to deal with a general case and mess around with it, and just kind of explore the conceptual, the essence of related rates, more than the actual just problem-solving aspect of it. So here we have a triangular prism, but more specifically the bases are right triangles. So I've labeled the sides of the triangle A, B, and C because we're going to use the Pythagorean Theorem, right? And then of course the height of the entire prism is h. So what we notice here is the volume. The volume here would be 1/2 ABH. Right? And so the volume depends upon A, it depends upon B, and it depends upon H. But that's too easy, right? Let's make this a little more challenging if we were to create a problem. Let's do everything with respect to C, right? So the idea here, what we're going to have is that C is going to increase. C, the hypotenuse of the right triangle, is going to get bigger. And how, I guess ultimately here what we will answer is, okay, as C increases, how does the volume increase? So let's think here for a minute. Let's just consider the bases, A, B, and C. And at least for me, at first thought, this is what I had imagined, is that, okay, C is getting bigger. Now, that implies something else. If C is getting bigger, that would force, at least from this perspective, that would force A and B to also get bigger. So if C is changing, it's forcing A to change, it's forcing B to change, and of course, that overall is going to increase the volume of this expanding prism. But then a little bit of deeper thought, right? This would only be true if the angle was fixed. Right? So if the angle was fixed and the hypotenuse increased, it would force both the legs to increase. But that's a lot going on. Let's see if we can simplify that a little bit. Maybe instead of making C extend both ways, it extends one way, and we also increase the angle. So as C expands, the angle increases, which means that in C getting bigger, we're actually only increasing A while B stays constant, right? So let's design the problem around this idea that we're going to let A take on the burden of the expansion, that B will actually be constant. So here we have we've defined what is what exactly here. So the variables here, the things that will be changing, are C, and that's gonna make A change as well. If C changes, A has to change, or B has to change, at least one of them. And then we're gonna hold B and H as constants. Good. So let's relate everything, right? This all revolves around related rates. So volume again is going to be 1/2 ABH, and then we also know we know that the volume now, the change in the volume is going to depend upon the change in C. So we got to get C, rather the derivative of C, into this formula, and we're going to do that with the Pythagorean Theorem, right? Now, we go ahead and take the derivative of everything with respect to time. So we're at 2a prime, where a prime again represents the change in A with respect to time, or dA dt. B we're going to treat as a constant, so it's gone, and then 2c, c prime. So this is how the rates of the change in A relates to the change in C. Now let's see how the change in V relates to the change in A. Because B and H are constant, let's go ahead and put those in front. And then A here is really the only function in this equation. It's a function of time. So V prime, or dV dt, is going to be 1/2 BHA prime. And then here we can make the substitution. First we solve this, so A prime would equal CC prime over A. Substitute that into here, and we get that V prime equals 1/2 BH, and then here's our substitution, CC prime over A. Good. if you were to make a problem, and I think we will here, if you were to make a problem that said you have a right triangular prism, or you have a triangular prism whose bases are right triangles, and the hypotenuse of the base is increasing, how would the volume increase? And this would be your formula. This would be your relationship here. So let's go ahead here and let's give values to our constants. Just see what it is. Be anything. Let B be 4. H be 5. Those are true centimeters. And then let's say at this moment, maybe at this moment in time, C is 5. Now, if you're keen on the Pythagorean Theorem, that means at this moment, A would have to be 3, 4, 5, right? And then maybe the rate at which C is changing right now is 2 centimeters per second. Again, we're just making up numbers. We're just throwing numbers out there. So how would this translate? Well, plug everything in. That would be 1/2. B would be 4. H is 5. C is 5. The rate of C is 2. And then A is 3. So let's see here. That's 10 times 10 thirds, or 100 thirds, and that would be cubic centimeters per second. So if all these things were true in this exact instance of time, that would be the rate of change in your volume. Good. Yeah, I'm just trying to show here that you can be creative with it. You can put whatever constraints. We could redo this entire problem so that maybe H was increasing, and A, B, and C were all held constant, but here we made C be the thing that was changing.